everyone, I am Anamika Goel from ABES Engineering College, Ghaziabad. In this lecture, I am going to discuss about the TCP window management system. In this lecture, first we'll discuss about the TCP window management, what is the concept of window management. After that, we'll discuss TCP sliding window. Then we'll discuss the working of TCP sliding window. And at last, we'll discuss about some advantages of TCP sliding window. So let's start our topic, TCP window management. Window management in TCP, it is an important concept that ensures reliability in packet delivery as well as reduce the wastage of time in waiting for an acknowledgement after each packet. So what is the concept of TCP window management? TCP window management act as a traffic regulators. What is it mean of traffic? Traffic is nothing but it is the flow of data packet is called traffic. So it is just like a traffic regulator for data, making sure everything flows smoothly in between computer without causing the congestion. What is the concept of window here? A window is represent basically the maximum amount of data that can be sent from client side to server side without waiting for its acknowledgement. Now we'll discuss TCP sliding window. For the purpose of TCP window management, here we use the window that is TCP sliding window. Why it is called sliding window? Because this is a movable window. When client send a segment to a server and server acknowledge this segment, so in that after receiving an acknowledgement, client window will move forward to accept or to increase the to accept another segment. So because it is a movable window, that's why it is called sliding window. A sliding window is used to make transmission more efficient as well as to control the flow of data. Here we use the window that is in dynamic in nature. It means we can increase or decrease the size of the window at the time of data transmission between client side to server side. Here we use a protocol that is TCP. We know that TCP it is a byte oriented protocol. So here the TCP sliding window it is in byte oriented in nature. It means it process the segment at the byte level one by one, right? Now we'll discuss about the working of TCP sliding window. To understand the working of TCP sliding window, we just revise the concept of TCP communication service. When we want to communicate sender side to receiver side using the TCP protocol, so this process can be categorized into a three steps. The first step is TCP connection establishment phase. After that, the TCP data transfer phase, and the third one is the connection termination phase. So when we want to send data client side to server side using TCP protocol, first we have to establish the connection between TCP client side to TCP server side. What is the meaning of connection establishment here? The meaning of connection establishment here is we just want to reserve some resources like CPU, bandwidth, and buffer from client side, also from server side. Because server side, why? Because here TCP work at a full duplex mode. It means both the sender and receiver can transmit or receive data at the same time. So here we require, so in that case, we required to reserve the resource from both sides, client side to server side. So in that case, what happened? So in that case, first, if client want to send some information to the receiver, or receiver also want to send some information to the client. So first, client and server make to establish the connection. So in connection establishment set steps, what happened? First, client send SYN packet or SYN segment to the server. And what happens here? When client send SYN packet to the server, it also send its window size to inform the server that this is the maximum capacity to store or receive the segment size. For example, it may be 5. So so for example, the sender window size is 5. It means sender can send 5 packet to the receiver without waiting for its acknowledgement. Right? Similarly, receiver can also send SYN plus acknowledgement segment for establishing the connection to the client. So in that case, receiver also send its window size. That, for example, it may be 5. So receiver can also tell the client that the maximum the window size of receiver is 5. So it can also send 5 packet without waiting for its an acknowledgement. This window size is dynamic in nature. We can change. We can increase or decreasing this window size at the time of data transmission also, right? So the first phase of working of TCP sliding window is the connection establishment phase, where both client and server can agree the initial window size. In that case, for example, we can assume that is 5 for client or 5 for receiver. So client can send 5 packet without waiting for its acknowledgement, and receiver can also send 5 packet without waiting for its acknowledgement. After that, now client say after the connection establishment phase, now in data transfer phase, client send data up to the window size and wait for its acknowledgement. In that case, what happened? Now client can send 5 segment one by one to the receiver, and after that wait for its acknowledgement, because client window size is 5. Now client will stop to sending the data. In next step is as acknowledgement is received, the window slide forward and allowing more data to be sent. After that, what happened? When client will receive 5 data packet, when a server will receive 5 data packet, now server will acknowledge to the receiver with acknowledgement value 6. Why we use acknowledgement value 6 here? Because acknowledgement, if the data pack, if the segment sequence is x, so the acknowledgement sequence is always x plus 1. It means in acknowledgement value will represent the next segment will expected. So here receiver will acknowledge the client with acknowledgement value 6. It means receiver expected that the client send packet segment number 6, right? So in that case, what happened? When the send client will receive acknowledgement, it will move its window to receive more data to be sent. After that, the receiver can adjust window size dynamically based on the network capacity. After that, it may be possible receiver at the time of acknowledgement, receiver can also send its window size. Like it may be in that case, receiver can send a window size 10. It means now receiver is able to receive 10 packet without waiting for this acknowledgement. It may be possible sender can also advertise their window size, like it may be 10. So receiver, both sender and receiver can send 10 data segment without waiting for this acknowledgement. So here use window size is dynamic in nature. We can increase or decrease the size of the window at the time of data transmission. This is a dynamic in nature. So this is the overall working of TCP sliding window. I hope you understand. Now we'll discuss some advantages of TCP window management. What is the basic advantages of window management services? Here we use a window which can initially हमें बता रही है कि हम एटमैक्स कितने पैकेट विदाउट वेटिंग फॉर एन एक्नॉलेजमेंट सेंड कर सकते हैं. So the first advantages of TCP sliding window management, it ensure efficient data transmission without overwhelming the receiver. It means TCP window management provide the ensurety of flow control, right? Second advantage is it prevent congestion control and data packet loss in a network, because at the time of connection establishment phase, we sender or receiver know the actual window size. So in that case, the chances of data packet loss is almost minimal. So it provides congestion control mechanism. And the third process is to ensure the reliability of data transmission over a network. TCP window management provide the reliability. Reliability means sender send a segment. After that, when sender receive acknowledgement, it means it can ensure that the data reach the receiver successfully. When sender cannot receive an acknowledgement, so sender can guess it may be the data is lost or corrupted. So in that case, what happened? Sender can retransmit the frame. So if we can retransmit the frame, it means it will create a congestions or congestion. So congestion in a network. So in case of TCP window management, the packet loss chances is almost minimal. So it will provide the surety that that client can send the data. It will receive in an efficient manner to the receiver. These are the some advantages of TCP window management services. These are the references using to design this lecture. Thank you for listening patiently.